Good morning, students. Today we are going to learn about AC distributor voltage calculation. Okay, AC distribution voltage calculation. In this, first of all, let us consider a AC distributor with one source point, which is nothing but this is A, and the two load points. Okay, two load points are B and C. The current from C is I2 and the power factor here is cos phi 2. The current flowing in section BC will be the same current. This is I2 and the current at this load point B is I1 and the power factor here is cos phi 1 and the current flowing through this section is I1 plus I2. The length of this section is L1 and the length of this section is L2. Now the impedance of this section is R2 plus jX2. The impedance of this section will be R1 plus jX1. Okay, R1 plus jX1. Now current in section BC is I2 and impedance is R2 plus jX2. So now the voltage drop will be voltage drop in section BC is I2 into R2 plus jX2. Okay, now what will the voltage at this point? To find the voltage at this point, VB is equal to this voltage, nothing but VC plus this drop. Okay, so voltage at B point is VB is equal to VC plus drop in section BC. Drop in this section BC. Okay, that is nothing but I2 into R2 plus jX2, which can also be written as VC plus I2 into Z2. In the same way, voltage at A point is, to find the voltage here, voltage at B plus this drop. Okay, so VA is equal to voltage at B point plus current is I1 plus I2. The current flowing through this section is I1 plus I2 and the drop is R1 plus J into X1. R1 plus J into X1. Okay, this is the voltage at V point. Now how to draw the vector diagram? Now here we will take I2 as a reference. Okay, I2 as reference. Okay, the angle between I2 and VC is phi 2. The angle between I2 and voltage here is phi 2. So the voltage will be VC and the angle between these two is phi 2. Okay, and the resistive drop will be like this, which is I2 R2. This will be in parallel with this one, okay, and the reactive drop will be in perpendicular to this section, which is nothing but I2 into X2. Okay, the sum of VC and this drop is equal to VB. Okay, VB, and the current I1 lags VB by 5:1. Okay, and the sum of these two is this one, which is nothing but I1 plus I2. Here the resistive drop will be in this fashion, I1 plus I2 into R1, and the reactive drop will be exactly perpendicular, I1 plus I2 into X1. The sum of this VB, the resistive drop and inductive drop, is equal to VA. So this is the vector diagram.